Very good morning. In this lecture I will be continuing to teach you Java to Prolog connectivity. First of all, I will like to show you the version of Prolog. We are on Prolog. I have this Prolog. You can see this is multi-threaded version 6.0.2 and this I am using 32-bit Prolog version 6.0.2 and this will work as my Prolog engine at the back end. In order to use this Prolog, I will show you in my computer in the C drive program files. When I installed this Prolog, it came into the SWIPL folder. This all material came with this Prolog, and you can see this is the path C program files and SWIPL. This is my Prolog. Actually I have many Prologs in my system. This one is one Prolog which I installed and I will be using. I think this one is 64-bit. In order to check, I will show you the documentation. First of all, I set the path variable so that my operating system know that which Prolog will be used. This environment variable, new, here you type path and here you have to type exact path of the bin folder of the Prolog. My computer has already set this path C program files SWIPL and bin. SWIPL is the name of directory which was created when I installed my Prolog, and I am giving this path up to the bin. And also I am setting another environment variable by creating new SWI underscore home underscore directory. Here I am setting this value SWI underscore home underscore directory, and I am setting here the value of this path. The value of this path is C program files SWIPL, and after setting I will just click OK and close this, and I'll close this. Now my Prolog is ready because operating system knows that SWIPL will be used. It knows its bin directory. Let me see this SWIPL version is available or not for my reading. Okay, this is I think SWI Prolog. This is my readme file. Here is some information that I could not find. 32 or 64 which I wanted to see. I could not find still. Let me check this last time. Okay, anyways, let us leave it. Now because I have to connect this Prolog with the Java program, so I will open the NetBeans IDE and just I will go to file, new project, Java, simple Java application, and I will develop this new project. The name of new project file is Java application 19. Just I finish this so that this project is created and displayed in my project browser window. This is coming here. You can see in the library already I have changed this time JDK 1.6. This is the exact version of the Java with correct bit. Means if you are using 32-bit Prolog, then you have to use 32-bit Java, otherwise you have to use 64-bit. Both previous video we have seen there was an error because our platform Java platform was I think 64-bit and we was using 32-bit Prolog. This time I have changed both in the same bit width, and I will show you that this time there is no error. Now in order to connect one Java program to Prolog, first of all we will go to the properties of the project, and we will see in the libraries of this project window we will add a jar folder. The location of jar folder, I will tell you. The name of jar file is jpl.jar. It is already provided to you with the swipl library folder, and you can open this. You can see this is available, jpl.jar, and now you can come. Okay, in the project browser window you can see jpl.jar is already came inside. Okay, jdk already available. This is my library. Now this setup is complete. We can put any Prolog example in this folder and we will try to learn that how it runs. So now my NetBeans is ready to connect with the Prolog engine. JPL.jar is the implementation of Java to Prolog API, and it is necessary to be included in the form of jar file in a Java project in which we are developing Java frontend and Prolog backend. So now I will go, and this is my family folder in which I have some examples. There is a family. This is Java file. This contains the source code of the program which will be run by NetBeans. This program will connect to the Prolog engine and fire the queries of the Prolog. This is family.pl. This is the Prolog program written in the Prolog syntax. This will be executed by the Prolog engine, and this will work as the backend program. This is Java front-end program. This family.pl is the backend program. So front-end program we can copy and paste in the appropriate place. You can see now this family.java is available. I will come here in the window. I will show you that this family.java contains some import statements. This import statement also import JPL and package JPL, and explicitly it also invokes imports jpl.query. This is my simple Java class family, public static void main, and now in this string I am just like you connect your Java with the database using JDBC driver. In that case you have to give the SQL queries in the form of strings, and then you have to execute the queries. You have to fire the queries through the Java program to the database engine. Similarly here you have to execute this Prolog query. This Prolog query will have to be fired on the Prolog engine. In the Java domain this is not more than any string. If you know any programming of the Prolog, then before the knowledge base is being used by Prolog engine, first of all we have to consult the file which contains that knowledge base. Here family.pl is that file which is containing that knowledge base, and this consult is the built-in predicate in which I am passing the name of family.pl. This complete string, I am making the query object q1 using this string, and I am then calling the method q1.hasSolution, which is provided by your JPL interface, JPL API, in order to communicate with the Prolog engine. When this method is called, this query is fired on the Prolog engine and it returns one value, either true or false. If the Prolog engine is successful to consult this family.pl knowledge base, then it return true, and therefore the value of statement is true and this succeed will be printed. If it fails to consult this family.pl, it means Prolog engine fails to consult family.pl, then it will return false in this query and we will be printing the fail. So first aim on in this lecture is to successfully consult a Prolog knowledge base. Before we submit this query to Prolog engine, we will have to tell him correct path of the family.pl knowledge base. Therefore I will go and copy the path of family folder. This is my family folder. So I am going to tell my Prolog engine that where to search this family.pl knowledge base. This is my path of the family.pl knowledge base. Okay, now you can see this string is containing one predicate consult and the path of the file to be consulted, and this string in the form of query is being submitted to Prolog engine, which is implicitly called by the Java program, and we will see that when we execute this program, this file will be consulted successfully. First of all, I run this program. Okay, the main class is family itself because main method is there. Now we can see the output window of an admin. Previous video I have shown you that there was an output error. Now in this time this is running very successfully. You can see users. This is the location of the family.pl. It is compiled and there are 7 classes inside it, which I have not shown you. I will show you this knowledge base. This is consulted and Prolog engine is returned true, therefore success is printed. Other output is related to other queries which I have fired from the Java program. I will now go in the program and tell you one by one that what are the more statements in the family class, family program. Now there is another string t2. In this string type, Java string type variable, I am putting another query of the Prolog. I am asking the Prolog engine that is it true that Joe is the child of Ralph. So asking in this way from the Prolog engine, I have to create child of relation with the values of Joe and Ralph and make it as a query and wrap this string t2 into the query type q2 object, and then I will go t2 is if q2 has solution. Same method of the JPL I am using here. If this query can be successfully matched in the knowledge base using the Prolog file, the name of file is family.pl, then Prolog engine will return here true, otherwise it will return false. This query is being fired to the Prolog engine. I will see in the output, and also I will verify that the same fact is available in the Prolog knowledge base. In case if it returns true, it is provable, otherwise not provable. So we will go and see the output window, and also I will verify. You can see in the output window, child of Joral is provable. How it is proved? Now I go and show you in the family.pl. This we can open with notepad. You can see there is a directly effect given child of Joral. So when my Java program fire this query child of Joral using this statement has solution, Prolog engine get this query to be matched against the given knowledge base. You can see the total knowledge base of the Prolog is given in this file family.pl, in which there is only first fact is directly matching Joe at the first position and Ralph at the second position. Therefore the first fact itself is matching with my query fact, and therefore Prolog engine will return true, and this true is used to print is provable. And in the output window you can see that in the output window you can see that it is provable. Now come to the next string. There is asking descendant of Steve Ralph. The question, English language question is the Steve descendant of Ralph? So I am asking this in the form of a string from the Java program. Then I wrap again in the query type of the object. Query is the class in the JPL. This provide you capability to structure the Prolog query in the form of Java strings, and then fire these strings on the Prolog engine in order to be executed over the Prolog engine. So simply I am asking that Q3 has solution, then it will be provable, otherwise not provable. And in the output window again you can see that in the output window you can see that descendant of Steve Ralph is provable. Now I will show you how the Prolog calculated this descendant of. There is a descendant of rule which is being used by Prolog engine to find that Steve is the descendant of Ralph or not. This is somehow logical question, and you have to use deduction, mathematical deduction, application of the rules and facts and combining them to infer some of the new facts. This is related to the Prolog functionality, how the Prolog programs work in presence of facts and the rules. That is another issue. I will teach you this separately. First of all, I want to show you that some of the queries are fired and they are running correctly. There is another string type of the variable t4 in which I put another query. The descendant of Ralph is X. Who is the descendant of Ralph? So this query, again I make a query object by using this string type of the object. Q4 is the my query object. Then I will pass the first solution. Actually X is the capital X is the variable in which the descendant of X will be put. So the first solution of this query is q4.one solution dot get X. This is the syntax for taking out the first solution from multiple Prolog solutions which are possible in response to the firing of this query to the Prolog engine. There may be one or more possible descendants of the Ralph in the knowledge base. So Prolog will answer one by one. I will catch the first one by one solution dot get method of Java JPL, and I will pass this capital X as a variable where it will return me the answer, and this will be directly printed. Also, if there is more than one descendant, then I have to use a hash table SS4 then I will call this method q4.allSolutions. By firing this, q4 will be fired for all solutions to the Prolog engine, and Prolog engine will return a set of all the solution in SS4, and simply I will print all the solutions of this query, which will be one by one printed with the help of variable capital X system.out.println for I is equal to 0. As long as there is a value in hash table, you can get that value into X and print that. So by using this for loop, I will iterate over each value of the hash table and print that value which is actually substituted at the position of X, where X is the descendant of Ralph, and this work is done by my Java program to extract one by one. However, the set of values one by one are returned by Prolog. Another way of doing the same query is using the while loop. While Q4 has more solutions, and as long as this has more solution, you have to iterate on each solution and print that. Another query is I have also made that string T5 is the query which I want to fire descendant of a capital X, capital Y. In the Prolog domain, capital X and capital Y work as the variables, and this query when I fire, then I will put the each solution. Q5 has more solutions, simply while loop, and I will go to each next solution and print the value of X and corresponding Y. That Prolog engine will calculate on the base on after this query is fired on the Prolog engine. So I will run this program again and show you the output window. I will show you the output window, and we will discuss. This is my first solution of the descendant of X. Ralph is X is equal to Joe. All solutions of descendant of X is given by X is equal to Joe. You can Prolog engine substituted Joe at the value of X as the value of X, Mary as the value of X, and Steve as the value of X. This is actually the backtracking behavior of the Prolog engine, that if we ask more than one solution of the same Prolog query, it backtracks to the previous node and give you all the solutions. In this case, each solution of the descendant of X Ralph is also given by while loop. This is also same, and in this case each solution of the descendant of X and Y variables, while X is taking the position of descendant and it is uncenter, so this X is equal to Joe can take place and Y is equal to Ralph can take place. Similarly, all the pairs are being represented which are valid according to the given knowledge base. It means the given knowledge base is supporting these kind of the substitutions, and therefore these possible pairs are available. So basically I want to now separate this Java program from this knowledge base. Knowledge base has a responsibility of all the work which we have seen related to the reduction and substitution. Prolog engine compute the reduction and substitution and give you the exact output. And the work of Java user interface is to provide user capability to ask the question, to fire the consult the Prolog file, knowledge base, structure the queries and fire them, structure the user interaction with the Prolog. Now your question is why we connect Prolog with the Java. There is some theoretical explanation regarding this, because many times the user don't know that how to write the Prolog syntax, and you have to provide intelligent system to your user, but in a user friendly manner. Therefore, you provide Java frontend and ask the user for his questions. So user is generally writing in natural language questions. User write his question in the natural language. Developer map a natural language questions, and therefore their generated answers to Prolog syntax. Developer has to map natural language question answers questions first of all, then after interaction answers are generated by Prolog engine in the Prolog equivalent syntax, and they have to be mapped into the natural language. This is the bidirectional process which developer has to provide, and user need a very easy flow navigational and very GUI based graphical user interface. So Java can be used to develop GUI interface for interaction. User can write natural language questions and this user interface can be used, and Prolog can be used as intelligent engine at the back end. Prolog can be used as an intelligent engine at the back end that is used to solve your actual logical problems. So in this video I have told you that how to connect Prolog engine with the Java using the NetBeans and JPL.jar. You can go to the website of SWIPL Prolog, and also you can search JPL documentation. JPL documentation. For future I have decided that I will develop some of the expert systems in this series of the video lectures. In these expert systems I will develop a knowledge base in Prolog. This knowledge base will contain facts and rules, and this fact and rules are regarding my real world problem. Therefore I will choose some of the real world problem in order to extract the knowledge and convert that knowledge into fact and rules. This knowledge base I will develop in the Prolog. I will develop a GUI graphical user interface and NLP based user interface. I will develop this GUI NLP based user interface, and I will show you that how simple natural language statements can be used to parse. Then I will parse NLP statements into Prolog queries, and I will parse them into Prolog queries, and these queries will be used to fire on the Prolog engine from this Java interface. In maturity of this video lecture series, I will show you that we can also add the concept of probabilities and fuzziness. We can also add the concept of probabilities and fuzziness in firing the rules, that which rules are more probably fireable. We can use probabilities, confidence measures, and fuzziness of real world. So in that case I will teach you that how to develop fuzzy expert systems using Prolog and Java. Additionally, I will take some of the Java shells, Java built-in shells for Prolog based expert systems. In these lectures, additionally, I will show you that Prolog and Java based expert system can also be integrated with your web-based applications. Prolog and Java-based expert system can also be integrated with your web-based applications, and we can deploy directly into our website at our web server. And I will try to deploy this combination of Prolog and Java on the Tomcat or any other web server. In the next video lecture, I will show you some more examples related to the connectivity. You can categorize this course into the many modules. First, a main objective is to teach you Prolog syntax, how the Prolog works, then connectivity issues, then Java Prolog based examples, then Prolog examples for prototype expert systems. Prolog examples for prototype expert systems using Java frontend. When we will mature in this subject, I will teach you concept of probabilistic expert systems in Java Prolog environment, and by this we will also increase the domain of our study to fuzzy expert systems, and at that time we will deal different libraries which support Prolog on the web. Prolog on the web. So in case if you find this video lecture interesting and useful for you, please you can review, and also in case you need any help, you can type wazirahmat786 @gmail.com. This is my email ID. You can send me the email if you find any difficulty or you need any help. I'm currently working on the AI based projects, and I am willing to take some more challenging master degree thesis level and PhD thesis level complete project. I can help you in making your dissertation documentation, IEEE papers, result oriented. I can also help you in result oriented research work for doctorate and postdoctorate level. Result oriented related to the probabilities and statistics, as well as in computational probabilities. Also, I am willing to undertake more challenging work of research and development in this field. Currently, I am working as assistant professor in the Department of Computing in Adama University, Ethiopia, and I have more than 10 years of experience in this field. And I welcome your queries and suggestions as well as more innovative work. Thank you for seeing this lecture. In the next lecture.